Friday's video, I did 1 through 10. So today, we're going to start at 11 and get through the rest of this. And Friday's stuff was the stuff you really need to spend a lot of time on anyway, because it's been a long time, it feels like, since we talked about 6-4 and 6-5. I know it's only been a couple of weeks, but it just seems like a lot of time has passed since then. So like I said, we're at 11. Let me find it. 7, 8, 9, 10. There we go, right there. And this should feel like, oh, we didn't cover this too long ago. You know, we talked about how you add, subtract, multiply, and divide functions, and how most of that, the new learning for us, was about the domain. I mean, that was the big piece. So what I need us to do to start this problem is to take a look right up here at f of x, and it says let f of x equal x squared minus 3, g of x equal x plus 4, perform each function operation, and then find the domain, but we should do the domain first. So there's two things that make us restrict the domain. Does anybody remember one of them? Even roots. Any even roots, then we have to restrict the domain. There's one other one. Anybody remember? Division. Yeah, those two things. So I want you to look at f of x. Does that have either of those things? So then the domain for this one is all reals. All real numbers. Now let's go to g. G of x, if my blue will work, come on, blue marker, there we go, is x plus 4. What should we put for the domain of that one? Again, yeah, all reals. So far, when you look at what they both have, it's like, well, we could use all reals for everything. But then we get to number 11, and we see, yeah, we're going to have to leave something out on this one. So we're supposed to take f of x and divide it by g of x. Now, I'm not even thinking about whether or not it divides right now. When I wrote that denominator down, there was a number that I have to say I can't use now. What number would do something bad to this? Right, so we'll have to say x can't be negative 4. And again, not equal to is equals with a slash through it, a strike through it. Now, the only way I'm going to be able to simplify this is if I can factor x squared minus 3. So I think about x squared minus 3 and the fact that I need two numbers that multiply to negative 3 and add to 0. Are there two nice integers that multiply to negative 3 and add to 0? So that one's done. That was all we could do. We wrote it as f of x over g of x, but that's as far as that goes. So math is done, domain is done, we go on to the next problem. Looking at 12, this is the one where we have to be careful. This is the most common mistake made in mathematics right here. We have f of x as x squared minus 3, and we have to subtract all of g of x. So what's the mistake that I've talked to you about that people are going to make in this one? They're going to forget to distribute the negative 1 to everything. It happens every year. Don't let it be one of you. Distribute that negative 1 through the second set of parentheses. And then you can combine like terms. And finish it up. Oh, I don't know. I was going to put an equals, and my blue must not have grabbed both of them. Thank you for letting me know. Yeah, my blue's having issues. I better quit using blue today. Let's go with the black and the red. Come on, blue. Well, if I put it in the right place, then it'll behave. There we go. Still looks like a minus. Turn back on, blue. So x squared minus x minus 7. Now, I didn't have division, so I didn't have to stop to think about the domain. At any time while we were doing that problem, did we suddenly have division pop up or any even roots pop up? So what should we put for the domain for this one? Yep, all reals. Nothing weird was going on. And like I said, you could write it out, all real numbers, 3 words if you want to, but the symbol of an R with an extra line on it is all real numbers in mathematics. So those two are done. Doesn't seem like there was a whole lot of math we could do with them, but domain was really the point of those problems anyway, thinking about what we can use and what we can't. Now, I've got that goofy blue line right there. Move that down. Find the composite function. F of x equals negative 2x plus 6, and g of x equals x squared plus 7. So they're not even going to bother asking us about the domain on this one. They're just saying, put one of these inside the other, because that's what composite does. So I want everybody to remember, the closest variable to the x is the first one we have to do. So our innermost parentheses are going to be that f of x piece. Then we put it into g. Well, let's see what happens. Here's f, and I have to put it into g. When I say that, where does it go? The x, again, nothing on the left-hand side. F of x and g of x are really y. So this has to go here. And I'm not done, because there's some math I can do here. What is that power of 2 for? Yeah, we have to write that out twice. Which usually feels a little bit weird because we have a negative in the front. You know, that doesn't happen a whole lot, but it's happening, and we're really good at FOIL, so if we just go slowly, we should be fine. First times first would be a positive 4x squared. Outside times outside minus 12x. So is inside times inside. And last times last is 36. Then let's just combine some like terms. Always read the directions again when you're done with the problem, because every once in a while, you know, it'll say, here's your part B for this problem. But this one just said, find the composite. So we're done. That's our final answer right here. Alrighty, let's go to 14. F of x is negative x plus 3, and g of x is x minus 7, but this time they turned it around. Closest to the x is the g, and then we have to use the f for the outside parentheses. So which one goes into which one? G goes into f right there for x. Ooh, I see something dangerous. Do you see the something dangerous? People miss that a lot. Don't forget about that little negative in front. And distribute it like it's a negative 1. So that's the danger with subtraction, you know. And obviously, these are probably the two that you're going to see on the test, because addition, nobody messes up with addition. And multiplication, you know, you guys are really good with multiplication. Definitely something like this could be there, because that's a little bit more involved. You know, you have to think, they're not going to put something that would be like an exponential algebra problem on there. It's going to be something a little bit higher than that. And that's what we're seeing here. So again, didn't ask us about domain. Don't have to worry about it. And we go on to this one that says this time, instead of just f and g, we're actually going to give you a number. So let f of x equal 2x minus 7 and g of x equal x squared plus 2. Find the value of the composition. Well, before we do that, I hope we remember back in this section, sometimes they would ask us to put numbers in that we could not put in. So we should think about the domain in this one before we do anything else. 2x minus 7. Any restrictions? Division, even roots, all reals. G is x squared plus 2. Anything we should do to restrict that domain? No, it's kind of nice. We got all reals for both. I mean, we don't have any even roots and we don't have any division. So far it's all reals, which means we should be able to put their -3 in. Now take a look at that. -3 is going to go in which one first? Yes. So we need g of -3, and then we'll put it into f. So let's start with g of -3. Going to go right there. And somebody's going to put that in their calculator as -3 squared plus 2 without the parentheses, and they're going to get this problem wrong. The calculator has to have the parentheses to know, hey, it's negative times a negative when we square that, and that'll make it a positive. So if you're going to put negative numbers in with your calculator and not your noggin, make sure you use parentheses for those. Done. You go on to the next problem and you get your test back and go, oh my gosh, I can't believe I did that. Why? We didn't put it in the other one yet. We didn't put it in F. So now 11 has to go into F. There's some basic math there. 22 minus 7. And we've got it. All right. So far, so good? Not fearing the back half of this test yet? Okay. So now, that was the section that we did that was covering adding, subtracting, multiplying. It was the one that said function operations, and we learned about composition. The next one we talked about, the next section was all about inverses. So this says find the inverse of each function. Is the inverse of function yes or no, and explain. So good thing we've got these little prompts down here. That's a lot of little things to remember. And we had 2 steps to finding inverses. What's the first one? We got to put a y in here. That's the f of x piece. Let's do that. But then 2 major steps to an inverse. Switch the x and the y. And the second step was? Yeah, get y by itself. Solve for y. Y, I can't get y by itself while that square root is there. So how do you get rid of that? We're going to square both sides. So that wasn't so hard. Almost done. What's left? Subtract 16 from both sides. Now, they did have a fancy function name, so really we probably should write f inverse. Does everybody remember how to write that f inverse piece? It's just that fancy f to the -1. Now, I'm not going to take off on the test if you don't do that, because they didn't in the directions say, find f -1 of x. It said find the inverse, and yeah, y is fine when it says find the inverse. So, taking a look at x squared minus 16, can you get a picture of what that looks like in your head? Big parabola that's down 16 units, right? Is that inverse going to be a function? It is. So I write too big, but maybe I can try and fit this in here. F inverse of x equals x squared. No, you won't even be able to read it. I'll try one more time. There, that's a maybe. So it's a function y. How do we know that? Using the horizontal and vertical line tests? Absolutely. If you just draw me a sketch on the test that looks like that, and you say it passes this one passes the horizontal line test, this one passes the vertical line test, you'll be fine. But there was a definition that'll get you out of any of these. Does anybody remember the definition for a function? For every input, I got you started. For every input, it's exactly one output. Yeah, you'll be safe every time with just using that definition. Let's go to 17. See what we have there. So first thing we did last time was change this to a y. Then remind me, what did we do again? Flip them. X and y get flipped. Then add 7. Oh, something we have to remember. Whenever our arm does this motion, right, with the square root, fourth root, any even root, what do we have to make sure we do? Oh, yeah, we need a plus or minus on there. And again, I'll write it with the fancy name. Is that a function? Nope. What's the problem? Matt's back here doing this. Yeah, it's a sideways parabola, right? So it's going to fail the vertical line test. You could certainly put that on there with a sketch. The other thing to be able to say would be, for every input, there is not exactly one output. Now, every once in a while, somebody says, Cedarholm, how about if I wrote this? For every input, there are 2 outputs. And I can't give credit for that. Because there's one number that if we put it in here, would only have one output. Getting a 0, exactly. So be careful, about how you write it. And like I said, you're always safe with, for every input, there's exactly one output, or for every input, there is not exactly one output if it's not a function, because that's the definition. Oh, good. We just did these, and you were really good at them. So analyze the transformation, graph the parent function and the transformed function, find the domain and range of the transformed function. So what I need from you is to know, what part of the equation should we use for the table? A and X. There it is, right there. What do we expect that negative to do to our graph? Should flip it below the x-axis, right? Now, do you remember our nice numbers? I know you had the weekend to forget. Good. Perfect squares. So there's an extra box. You don't have to put a number in there. We said 9 is good. And if you would want to put 16 in there, put 16 in. If it's there, why not, right? Might as well put a spot in there for a perfect square. So then 0, well, there won't be a negative 0. It's just going to be 0. Square root of 1 is 1, but then times negative 1 will be negative 1. Square root of 4 is 2, negative 2, negative 3, and negative 4. Now that's our parent, so let's get on there, dashed, dotted, something along those lines. Boy, these are teeny. Well, can't do 16, negative 4, but we can kind of aim over there, right? All right, so the next thing we would want to know, and I know it's down below here, but it says describe the shift. And we definitely want to do that before we make any more changes to this. So where's it going to go? 2 right. What's this doing? 3 down. So down here where it says describe the shift, 2 right, 3 down. And then we can go do our counting. And one of the things that really helped everybody with the domain and range part was if we said, hey, these are the coordinates of that new starting point right there. So what are the coordinates of that new starting point? 2, -3. So obviously our x's have something where they start at 2, and our y's have something where we start at -3. We have to figure out what inequality should go there. So looking at the domain, are we going to higher x's or lower x's? Greater than or equal to. Looking at the y's, we go into higher y's or lower y's? Less than or equal to. It's that simple. All you have to do is say, here's the starting place. Oh, is it going right? Greater than. Is it going left? Less than. Always going to do the equals because this is the starting place. For the y, if it's going up, greater than. If it's going down, less than. Well, this one, hopefully, is still pretty fresh in your mind. Y equals cubed root of x minus 1 plus 3. So what should we use for the table part, the equation that'll help us with the table? All we take is a cubed roots of x. So in this case, it's just the cubed root of x. That's it. Do we remember all our nice numbers for those cubes? Okay, so think about -10 to 10. The nice ones would be -8, -1, 0, 1, and 8. Because those are perfect cubes. What's the cubed root of -8? -2. What's the cubed root of -1? And of course the cubed root of 0 is 0. And then we've got our positives down here. So there's the shape. We can go ahead and put that on, dashed or dotted. Sideways S-curve, snake-like curve. Let's do the same thing we did last time. Let's talk about the shift first, then we can get that final graph on there. So where's this one going to go? 1 right and 3 up. So go ahead and take your 5 very nice little points and move them 1 to the right and 3 up. And just do your best to make a nice smooth curve, you know. Now the domain and range for these was even easier than the one for square roots, wasn't it? What do we put? Right and left and up and down forever. All real numbers. I was just thinking, Emma, if they give you a pass, I better turn that off so it doesn't look like it took you a half hour to get to class. All right, so take a look at that last one while I'm checking the pass thing here. Okay. This should feel real familiar. We did this on Thursday. Rewrite the function to make it easy to graph using transformations. So I see the square root thing, and I'm thinking, well, that means we want it to look like that. I mean, that's what we want. Oh, yuck. There's a 16 in front of our x. Anybody remember how we get that out? Yeah, dividing by it, or I had somebody, I don't even remember what hour it was on Thursday, that described it as undistributing. That's exactly what it is. It's factoring is undistributing. So we need to take a square root of 16 out of everything underneath that radical. Just out of the 1, out of the x is not enough. It has to come out of both. And then we have to know what the square root of 16 is, which I think is a piece of cake, right? What is it? And now again, always read the question again before you say, hey, I'm done. Rewrite the function to make it easy to graph using transformations. They're not even asking us to tell them what the transformations are doing. We rewrote it. This is done right here. I mean, it wouldn't take us very long to say vertical stretch, factor of 4, and then translate 2 to the right and 8 up, but didn't even want to know that. Just how would you rewrite this so you could graph it? So that's the back half of the test with different numbers right there, as we did 11 through 20. So, what do you think? Thumbs up or thumbs down? Going to be able to ace that part of the test tomorrow? Lots of you are like, I don't know. Maybe that's because you didn't watch the video on Friday. You definitely want to watch that video for the first half of this. And there's just this one review assignment for both days. And I know some people already did this because they submitted it over the weekend. But, take another look at it. Pretty obviously, I hand-picked them, right? I mean, there's a couple of these I even came up with some so they'd be more and more like what you're going to see on the test. So make sure you do this review assignment. And if you have trouble with anything, stop me. And we will definitely